they all have solutions?
Is
They
it
all
unique?
have unique solutions.
Okay.
Yep.
They all have unique solutions?
Yes. But I do not mind giving impossible problems, and I will do that. But usually I'll set it up in a way that I will give students, for example, 3 problems, 3 leaves to eat, and I'll tell them, one of those leaves is indigestible. It's poisonous. You're not going to be able to eat it. You have to figure out which one is impossible. And that's the way I would set it up, rather than say, oh, you know, not all of them might be possible. I'd rather be definitive by saying there's one of these that's impossible. Yes?
So I was thinking about this, like, okay, I love this, and I want to, how do I make more of them? And I was thinking, like, and the loop made me think about this, like you made that first loop by making the squares and making sure it worked. So I was thinking you would take your shape with 16 hexagons or whatever it is, and then make your path, and then you would put in the bar.
That's the way you make
that,
it.
yeah, I mean,
Yeah. So the way to make these is to design your leaf, design your whatever you want first, put in all of the numbers, put in all of the bars, and then remove the numbers and copy that and send it out to the rest of the class to solve. And I encourage kids to look for beautiful solutions. So for example, the grapefruit there, why is it beautiful? Why is this an interesting puzzle for me to have made? Well, it's an interesting puzzle because you have that line going right through the middle of things that isn't connected to either side. I mean, that was kind of fun for me to make as a puzzle maker. So you should get your students that after a while, you should get them to appreciate the beauty of creating a puzzle that's not just random putting in these numbers, but trying to get a specific objective out. So that's why I like that. And the small leaf there that had the 7 kind of right in the center. Well, that's unusual because 7 is a prime and you don't think that it's going to be highly connected. So just things like that.
But if we create our own puzzle that way, how are we sure there will be unique solutions?
That's an excellent point, and that has to be proven. It's actually very, very tough to go out and try to make a puzzle that has more than one solution, and that would be a really good challenge for your students. Come up with a design of those walls that does not have a unique solution. Now, it's reasonably easy to do it at one of the ends. So at the start of your path or at the end of your path, it's possible. I have yet to do it. I have tried. I have yet to make a path that has more than one solution, starting at 2 and going, or starting at any number and ending up at any other number. I've yet to make a snake that has 2 solutions. So.
Is it always a snake?
Or a worm. Sorry?
Is it possible it's not a snake? All the numbers does not form a snake?
No, you have to make the snake. You have to wind it around to make the worm. That's part of the puzzle.
I cannot put 2 and then the neighbors are 4, 6, 8. I mean,
Yeah, I've experimented with multiple worms going through, so I've got a puzzle book of Mimizu puzzles if you want to look at some more. So they get really, really tough, and you can have multiple worms, and there's some of these that don't have any hints at all. So let's see, for example here, this one here, you don't even have any clues about where you start and where you end. So they can get extremely hard, and yet this has a unique solution.